Welcome, everyone, to the Beyond Seattle SRE Meetup. It is my absolute pleasure to be here. My name is Kit Merker, and I am from a little company called Noble Nine. And I, along with Urza, have been organizing this meetup. This is our third one, and we've expanded the charter to Beyond Seattle. But we're Seattle based as best as possible. But everyone else is welcome. Yeah, so there's me with a hat on. My company's just focused on SLOs and SREs. We're trying to make services better. I won't spend any time on that, but if you want to know more about it, I'm happy to chat. We have a packed agenda for you today. We've got a couple of guest speakers, and we're going to have our breakout networking, and we'll also do our hiring manager rapid round. We'll stay at the end for Q&A. We'll probably go overtime with Q&A if you want. That's a pretty open discussion, so if you can stick around, that'll be great. The whole thing's going to be recorded. We're already recording. It will get published on YouTube, so just be aware of that. If you say anything, you know you're consenting to being recorded. Let's get started. Let's move on. So first up today. Oh, sorry. Yes, sorry. Before we begin, okay, if you're a hiring manager and you have an open position for an SRE, DevOps, or related position, we play a fun game at the end. For hiring managers, it says 60 seconds, but you're only going to get 30 seconds today. Send me a private note on the Zoom chat and tell me your name, who you are, and what we'll do is you'll have 30 seconds at the end to talk about why your job is awesome to all the other people here, and hopefully you get to hire somebody out of it. So it's a little fun game we have. If you've got a job, tell me about it. Dylan Zehr from Google, our first speaker, the man of the big query.
Hello, everybody. Again, my name's Dylan Zehr. I want to, first of all, just thank Urza and Kit for putting this on. It's been really great working with you guys, keeping me organized and all the fun energy that you guys have. My presentation kind of came out of a conversation at the very first meetup that had been organized back in January, which seems like years ago for those of you that may have been there. And so, again, thanks to them for putting this on. As some introduction, I'm an SRE manager at Google. I work in the cloud area, specifically BigQuery, which is a multi-tenant serverless data warehouse. If somebody has a question about that, ask me later. My presentation isn't anything related to Google or the products that I work on. And let me see if I can bring up my slides here real quick. All right. So again, like I started to say, this was the topic that I got this presentation worked around came out of a conversation I had with Kit the very first meetup, where again the part of this that I really liked that first time was the after session where we were talking and all this conversation and questions. So again, feel free to ask me questions. This is kind of put together in that vein of trying to be informative and interactive. Again, introduction. I want to spend a few minutes, maybe 5 minutes or so, just kind of going through some of the terminology around SLIs, SLOs. I assume this is probably something that many of you know, but it's worth maybe a little bit of a review. To start with, an SLI is service level indicator. It's basically a measurement. It's some quantity. It's a little different than a metric in some ways. Both are these time series of numbers that people have. Hang on a second. I need to stop clicking on my screen. Essentially, you use the same kind of metrics that you might be using in your monitoring. Can be used as SLIs, but an SLI should have this kind of bounded nature to it. It should be something that as a percentage is a very common thing, 0 to 100 or 0 to 1, because it has a bounding around it where you can set a threshold and you can measure it. Things like request rate don't make good SLIs because there's no bounding to it, and it's really hard to set up a metric on that. Next, SLO is service level objective. Again, this uses an SLI and some kind of threshold. It can be a target level. It can maybe have an upper and lower bound. Most of the ones that I've dealt with, usually just have the single target value. It's something you should be sharing if you can. Definitely share it internal with the team and within the company. Sharing it with users can be important for transparency. The SLO should be something that's somewhat meaningful to the service and to the users. If you're tracking an SLO that doesn't correspond to user sentiment, then it may not be that useful for you. If you're meeting your SLO, you should have generally happy customers, and if you're failing your SLO, you should have generally unhappy customers or unhappy users. Again, there's a balance there. So picking the wrong SLOs, won't help you. You should put some thought into picking the right ones, picking the right values. Let's see. Part of kind of where this ties together, the important part in all of this is the error budget. What's the allowed amount of error? What's the acceptable level of error that you can have in your service? No service is 100% perfect. There are going to be unforeseen things that you just are going to happen. What you're trying to do with the error budget, though, is build in this allowance for the more acceptable things. Things like bugs in rollouts or the occasional hardware failure, things like that. Building in that reliability and saying, hey, we'll accept a little bit of failure. And again, that goes back to your users. What is their expectation? Some services have an expectation of a much higher availability than others. Generally, error budgets and SLOs are tracked on this kind of 30-day window, but that's up to you. You can do that in different ways. Sometimes it can be shorter, sometimes it can be longer. I think if you've read some of the SRE books, or Kit's actually done a presentation that I watched one time that was very good about this, of some of this SLO bit, the error budget is kind of how you get this tension between like DevOps and feature dev, and how you kind of resolve that tension. If you're below your SLO, then that means you need to slow down. If you're above your SLO, then that means you have some room for experimentation. You can try some crazy things, or roll out features a little bit faster, because you've got a little bit more slack in the system. An important, all of this, and this is some of where, the later bits of what I'll talk about, get into this. All of this is about your users. What you're trying to do is provide a good service for them. The SLOs should be meaningful. If possible, you should be, presenting them in some way. Again, this idea that if you're meeting your SLO, your users should be happy, and if your users are unhappy for some reason, then you should probably have a failing SLO somewhere, or at least something that gives you that indication. Ideally, you'd be able to just measure all your users, and that would be a great SLO, but that's not physically or practical. So what you're building is some kind of proxy for that sentiment. And I guess the one last comment kind of on that, an SLO is not an SLA. An SLA is a business contract. If you actually have a business guarantee for reliability or uptime or latency or any of those kinds of things, any of these measurable things, generally try to set your SLO to be much better than that. The teams that I work with, we tend to target, 1 extra 9 on our SLO versus our SLA is kind of the ballpark that we sometimes work with. Of, you want to be better if you can, because SLAs have money attached to them. There's also a cost, kind of to segue out of just straight SLI, SLO conversation. There's a cost associated with this reliability, or with this, value that you have in an SLO. If you're setting up a new SLO, don't pick your target before you've actually implemented your measurements, your monitoring, your alerting. I mean, you want to set this all up with what is it today, because that's what you want to have a handle on. You don't want this to be, you don't want to start with something that's aspirational, because that's going to be ugly and messy and cause lots of pages and lots of toil and lots of upset people, build your SLO around what your current values are, and then look at what you can do to improve them. If your users are not happy, what's the target, and how do you improve that? I don't have a good statistic for this. This is kind of slightly made up, but there is this idea that adding an extra 9 to the reliability or to the the error rate has a significant cost. It's not just, oh, it's 10% more machines. It's twice as many machines, or 3-4 times more machines. So even what seems like a small improvement in SLO can have a significant cost in hardware, time, people, all of that, and you should be weighing that. It may not be worth making your SLO better. Again, this goes back to that concept of a user. So the next section is really just kind of some bits and pieces, because one of the things that I've seen in some of these other kinds of presentations in the books is, a lot of the SLO examples are the very simple web service. It's just that, a web service that gives you back 200s, it gives you back 500s, you measure the error rate, it's a real easy example. It's not always that useful in some ways. I think there are a lot of real world examples, and that's kind of what I wanted to get into, of just showing some of these other examples of how you might be using these things. So again, this is a pretty common introductory example. Take your error rate divided by your request rate. You've got a percentage of errors. You have a target of less than 1% errors, or less than 10% errors, or less than 1/1000th% errors. Whatever that might be. So the first kind of, I'll say, I use the word shortfall, but kind of, counter example is, again, knowing your user behavior. So in this example here, say you have a 3 nines SLO, that gives you 43 minutes of downtime a month, but your web service fails for a few seconds every hour, just boom, drops all the connections, 500s everywhere. But if this is, especially if this is not a user-facing web service, maybe it's a back-end service, then the users that have implemented client libraries, or maybe the client library that you've supplied to your user, has incremental back-off algorithms, or it has retry logic built into it, then the user may never notice that this is happening. So again, here you have a situation where you've built an SLO, you've got a graph, you've got a dashboard, it's all red, but your users aren't affected at all. They don't know it's been down. They're not unhappy with it, but maybe you've burned your SLO budget and now you can't do rollouts. So again, you really want to know what the users are doing. How are they using your service? And you need to build SLOs appropriately. This one kind of goes back into some of the basic examples, but again, that same web service, maybe it's not that failures are a bad thing. Maybe it's the user experience where there's this occasional spike of high latency. So in this case, the request error rate is not a good SLO, but a latency SLO is what's appropriate. But again, how do you pick those values? Is it the P99%? Is it the mean latency? What's the right value for their user? Are they happy with 5 seconds, 10 seconds, a minute? This next thing that's kind of interesting to me, this gets into some more advanced math a little bit, and if someone has some questions, follow up with me on some of this. But did I go on too far? No, this is 2 slides. Is services that have really variable queries per second, right? If you have this idea, if this happens where you have a very low QPS period, then suddenly you have false positives. Say you get 10 requests in a minute and one of them fails. Well, that right there means you've got a 10% error rate. That's horrible if what you were targeting was a 99% uptime. So one way to do that is to not actually use linear percentages. What I've referenced here as a picture is something called Wilson score interval. There's a Wikipedia page on that if you'd like. It's a binomial interval, and what it does is it weights the percentage value so that at very low QPS you actually get a very much smaller number. So 1 error in 10 is not 10% errors, it's 2% errors or 1% errors, and so again you're back below your threshold. I've got a second slide that kind of has some more math example of how that would work. And what you're shooting for is this idea that you can adjust where this elbow is in the curve, and how does that fit with how you want to, when do you want to actually trigger an alert or trigger SLO burn based on the QPS. So again, I don't know if I'm actually okay. Just checking something. Sorry. This next section, and this is something that maybe is a little more related to some of what I've been working on, really recently, or some of the teams, is this idea of a critical user journey monitoring, and you can also build SLOs around that. Rather than doing something that's more cause-based, this is more about symptom-based monitoring, where you build probes and you build front-end infrastructure, that's looking at, how does the application work, and what's the experience of the user, not how much CPU is it using, or how much memory is it using, or what are some of the actual result codes. There's some very powerful things in here that you can do by setting this kind of system up, but it is sometimes a significant investment of effort, to go ahead, to go through knowing your application and building custom logic, or putting together toolkits and third-party products. It's not meant to replace integration testing or unit testing or any of these kinds of things. It's all about building these SLOs and the customer experience. There's also some ways when you use this kind of technique, and again, I'm open to some questions later if anybody has them. This is a kind of technique where it can be also very narrow. You can get very specific. You can have very high tolerances, and you can even do some stuff based on your users. You can segregate out some different categories of users and build different journeys for each one of them. As a concept, this is where my Google will leak in just a tiny bit. We use this but rather than these kind of continuous metrics like response rates or latencies, we've built a few things where we have this idea of a bad minute, where you take, and often this is post-processing. This might be several minutes behind. It's a bit of a lagging indicator, but what you do is you take logs, application logs or web logs, things like that, network logs, and you crunch through them, and you basically come up with values for each minute out of the hour, and then you build SLOs around the bad minutes. Again, you get this idea of, rather than a 99.9% SLO is 43 bad minutes, but how you calculate that. And again, this kind of ties back into CUJs. So the reason I kind of wanted to point out the critical user journey monitoring and building SLOs and around that is, again, this kind of idea of symptom versus cause-based monitoring. So an example here, you might have a web service that's returning 200s well above a 99% error rate or 99% success rate. And you have a database that you're monitoring, and it's doing its thing at above a 99% success rate. But between the two of them, the application is dropping all the data on the floor, and the user's transactions aren't being saved. To the user, it's completely broken. So these individual system SLIs aren't catching that problem. And so again, that's where there's this idea of, you build something that mimics, what the user is doing, goes through the process like a shopping cart or an application, and tracks that kind of stuff. an interesting, or one other bit on this, having built a few of these, be wary of cached data, because you're doing like the same operation over and over and over again. If you've got caching layers in your system, you can miss things. You can miss latency. You can miss, errors, due to loading data, things like that. So there is some thought that has to be put into building these. This comes out of some of the data analytics area, where I've seen this, or anything that does a lot of parallel processing. Tail latency can be more of an impact on some applications than others. Say the app, what the user is doing is, issuing 100 service requests, and the result has to be aggregated together. Well, it's only going to be as fast as the slowest request. So even if you have a pretty good, P99 number for latency, that little bit of latency is actually giving them, they're only as fast as the worst latency. And so, again, be aware of that. Be aware of how your users are using your service. You might have what you think is a really good looking latency graph, but for some users, it's not, because of this aggregate. This is also one that I've found can find issues within the system. Say you got a particular piece of the system that's hotspotting. One user is tied to one machine somewhere that's got a lot of contention, or there's one set of data where all the users are reading this one bit of data. So that piece is what's the slow, the long tail always. And so even though it might not be as frequent of a request, it could still be having an outsized impact on the users. I've got a couple examples on this. This is a little trickier, so again, ask me questions later. And this was actually kind of what got Kit and I started talking about this a while back. Storage is kind of one of those that I don't know that I see a lot of examples on. I don't see talked about a lot of, how do you build SLOs around storage? There are ways to build it around, for temporary storage, it's a little more like a, traditional SLO of, how much of the time is there storage unavailable, or how many write failures are. You can kind of build things, data caches, for instance. You can build SLOs around, what's the cache hit rate, or what's the fullness of it. So that one's not too bad, but you can use these same kind of ideas there for storage. Persistent storage is a little bit harder, because you can't, it's an absolute size. It's generally growing. I don't know all that many services that have less data over time. And so what you end up having to do is, how do you turn that into something that's a flat percentage? What's the runway? How many days of storage do you have, or how many hours of storage? And one way to do that is to build a simple model of, what do you expect? What do you expect the amount of storage to be added every day? Your users are storing data, or the system is creating a data set or a log file or something. If you have an idea of what you expect it to be every day, then kind of similar to the bad minute idea, you can basically compare that to what your expectation is. Say your expectation is that the application writes 100 gigabytes per day, and one day it writes 90, and one day it writes 110. You can compare those and go, okay, as long as the days that are over are fewer than the days that are under, then my prediction is in the right place. Whereas if you find that suddenly you have a lot more days where you're over your prediction, then that you're starting to get out of SLO, that you need to do something with the system. This last, I'm getting close to the end, so I may be a couple minutes early. This last bit is SLOs can be used in operational areas too. They don't just have to be systems. I mean, this technique can be used in a lot of different areas. And one of the first ones, and one that I have some experience with, is things like bugs. You can build an SLO around like bug closure. not how many bugs does somebody fix and close, but how long does it take them? If the SLO is a day or a week or a month, you can then say, well, how many of them got closed in that time frame? And if you're out of 90% of them or 80% of it, doesn't have to be 99%. These are areas where it can be a lot fuzzier. But say you have a 90% closure SLO of 1 week. Well, if you're below that, if you're not meeting that, then that means maybe you need more people working on bugs, or maybe you need to reevaluate some of the process by which code is being put into the system. Maybe there's too many bugs. Maybe you should focus on bug avoidance, or test cases, unit testing, different kinds of things. But it gives you a way to track that without necessarily building this kind of absolute metric on top of things. Again, counts of bugs is not a good way to measure people. And you can do the same thing in some of the agile world of like sprints and story points. You can also do some of the same thing with your estimations. How well do you estimate the number of points, and how many are you getting completed, and is it meeting a certain percentage? Less about the totals and the absolutes, but are there ways to take what you're tracking and building it into something that's evaluating how good you are at predicting your workload? Because that's kind of what you're wanting to get at with bugs, feature development, any of those things is, can you be predictive and know that you're on the right course, that what you've got planned for a week or a month or 6 months out is reasonable. You can build alerts on SLOs. This one might be a little more where you might do some absolute. I've got an example here related to my team of 4 alerts per 24-hour period. But if you're an SRE or someone doing SRE-like work, and you're the one with the pager, getting woken up in the middle of the night or the very early morning or those kinds of things, you want to build some SLOs around that kind of work. You want to build stuff around the operational load. Use these same tools for how often are you getting alerts, and how long do your outages last, and how much work does it take, how many hours are you spending per incident. All of these kinds of things make very good SLIs and very good SLO numbers. And part of why I kind of poke at this one with the alerts and also the bugs, but especially the alerts, it's a big thing with the team health. You can sit down with a team and say, okay, this is what our SLO is going to be for our alert load or our incidents, and it's a way to measure it, and it's open with the team. The team knows what the numbers are. Management can know what the numbers are, and there can be shared agreement on where these things are. And if they're out of SLO, then that's a signal that something needs to change. You need to sit down and reevaluate what's going on. So if you're using these toolkits, using these frameworks, whatever it is to do all this other system monitoring, use that on your own processes, because you can really help your team and your workload. And again, operational, that was kind of a repeat of the previous slide. Again, you can track all those things that aren't necessarily alerts, but also kind of fit into that. Say there's a request where you need to go start a VM every day or add new disk space or whatever. You can kind of build those same sorts of things in. I believe that's the end of what I kind of wanted to cover. Again, this was more just some general thoughts and examples of some things I hadn't necessarily seen in some of the books or other presentations. And again, wanted to kind of throw it out there. And again, later in this time period, I'm available for some Q&A, or if anybody wants to reach out to me offline, I'm happy to answer some questions there as well.
Thank you, Dylan. Round of applause or silent claps. Are there any questions right now? If there are, jump in. Otherwise, we're going to move on. We will have time for some questions later too. So, Erzik, do you mind putting the agenda back up for? All right. So next up, actually just put the slides up. Next up, we have a very special guest who's going to give a very short presentation here, Angela Tran, who I got to meet a little while ago, and she's been working on a really interesting research project. And I thought it was pretty cool. So I wanted to share what she's done and have her introduce herself, and she's gonna take it away. So everybody, give a warm welcome to our first time presenter, Angela Tran.
Hi, my name's Angela, and I'm a rising sophomore at Boston University. I'm majoring in computer science, and this summer I'm interning at Dell Technologies. So during these times, workers have been forced to work from home. While the sudden transition was hard, it now gives companies the ability to experiment new ways of working. At Dell Technologies, we envision a future where a large majority of employees will become remote workers. As such, I'm using this time to figure out what problems employees have been facing in the tech industry to see what can be done to help remote workers within Dell. To find what problems that employees in the tech industry have been having, I've been reaching out to technical communities to circulate my survey. And Kit and Urza actually really helped me with a lot of this, so I owe them a really big thanks. My survey tackles 3 key ideas. The first idea is centered on innovation. I define innovation as being able to see a problem and being able to come up with a solution for it. As such, my first 2 questions ask employees about their ability to face new challenges innovatively and their ability to collaborate on challenges with their coworkers. The second main idea is centered on what employees can do to help their employees in these times. The third main idea is centered on what employees love or hate about working from home. So at this moment, I have 27 responses for my survey, with 50% of the responses coming from employees of large companies, meaning more than 250 employees, 10% of employees of medium-sized companies, meaning 50 to 249 employees, 30% of employees of companies with 10 to 49 employees, and 10% of employees with companies with less than 10 employees. With the 27 responses, I've found that when it comes to facing new challenges, most employees have found that their ability to face new challenges at home is about the same or better than working in office. This can be seen in the bar graph on the top. However, when it comes to communicating and collaborating with coworkers, there's an almost even split between employees who found that the ability to collaborate has gotten better, stayed the same, or gotten worse than compared to in office. This can be seen in the bar graph on the bottom. Can I have the slide change? Thank you. For the things that employers can do to help their remote workers, the 4 biggest things that I found are 1, providing a stipend for work from home equipment, 2, instituting days of no Zoom meetings, 3, creating virtual reality meeting spaces, and 4, providing an optional relocation ability. When it comes to what employees love about remote working, the most popular answers are not being needed to commute to work, having this flexibility within the day to do personal tasks along with work, not being interrupted by coworkers, and having more time to spend with family. For the hates about remote working, employees have found that it's harder to create a distinction between life and work. People aren't able to interact with others as much. They're stuck at home all day, and the ability to brainstorm and whiteboard with others have gotten worse. To me, this project is important because in just a few years, I'll be joining the workforce. And I believe that this is the moment that has an incredible potential to change the way we work. As such, I want to see what kind of future the tech industry has in store for me while having a hand in molding that future. And in terms of next steps for this project, now that I know what challenges employees have been facing in the tech industry, I need to do the research to find all the potential solutions to those challenges. But for now, I'm still looking to gain more survey responses. So I would really appreciate it if y'all could fill out my survey, and if you already haven't. And I'll be putting the link in the chat for anyone to fill it out.
Thank you, Angela. I already put the link in the chat window for you, so there you go. But good job. Thank you very much. Okay, Moving on. Okay, so we're moving to the next portion, and we're doing things a little different because we're remote. As Angela pointed out, we're all trying to do things now remotely together, and we all miss the social component of our meetups here. So we're doing the Zoom breakout meeting rooms. Now, last time we did it when, if you remember, Jolene and Getty Images hosted us. We had a great time with the breakout rooms. We've tried a different approach. Last time we assigned you to rooms randomly. This time we've created 5 breakout rooms, and each one has an icebreaker question. So you may end up in a room, or you may need to choose a room. Basically, pick the icebreaker question that you feel the most affinity for, and join the room and answer it with the group of people in there. We're going to give 15 minutes in the breakout rooms, and you'll automatically come back. Please do not sign off after the breakout. We want you back. So say hello, make a friend, answer the icebreaker question, come back to the main room, and then you'll see Zach and his presentation, and we'll have the Q&A and the hiring manager game. You're good. Take it away, Zach.
All right, sounds good. So for today's topic, we're going to be talking about building meaningful alerts with the goal to keep your customers happy and keep on-call sane as part of the process. So just a little bit of background myself. My name's Zach Quiring, just one R. I work for a startup based out of Seattle called Edge Delta in the observability and monitoring space. So think about logs, metrics, traces, all that type of data, alerting, dashboarding, and some of those things. And I'm kind of a hybrid product manager as well as a solutions architect. So I spend a lot of time with our customers as well as with the engineering team, kind of implementing the platform and various functionality there. And just one caveat before I get too into the weeds here. I'm actually house sitting for a friend right now, and they have a 3-month-old puppy that's pretty rambunctious. Luckily, it's sleeping right now, but there's a chance that there might be some chaos, but I think we should be fine for the time being.
Do we get to see the puppy? You can't just like talk about this adorable puppy and then not even include a picture or anything.
Yeah, at the end, I can grab her really quick. But yeah, so basically what I'll try to cover today, why do we build alerts? Go into some detail around some of the fundamentals, specific terminology, and then some examples of like specific things to monitor or alert on, and different things like that as part of the process there. And then go into some examples around kind of creating an actual rule as part of an alert and kind of the conditions and the iterative process that goes into that, as well as optimizing the actual page or notification that somebody receives when an alert gets triggered. And then if we have time, we'll go into some advanced kind of alerting mechanisms and tools you can use to optimize the process. So why do we do this to ourselves? Why do we potentially create these things that might wake us up in, 3 in the morning or in the middle of the night, or stop us from, having to drop everything that we're doing and address something right away? It's because we enjoy waking up at 3 in the morning on a Sunday. Most likely not. There might be some people that do, but personally, it's not my favorite thing ever. But a big driver is customer satisfaction, brand credibility, keeping our users happy. Basically, a lot of in the technology space, it's a very competitive market. Everyone's trying to maximize their SLAs, their SLOs, their uptime availability. And it's just not really possible in most cases to always have people with eyes on dashboards or running queries, aware of the health and everything that goes into a system. So we have to rely on automation, on tools and technologies that can basically actively always be scanning what's taking place within our systems and hopefully alert us as fast as possible as part of that. And so it's alerting is basically a due diligence component of operating, developing applications and keeping all those pieces together. I've also kind of heard this concept of shame prevention. Basically, if you, maybe a significant outage took place and you didn't have the kind of alerting mechanisms in place to notify you that there was an issue, hopefully after you've gone through followed up with a post-mortem. Hopefully you've been able to identify characteristics or things that you could potentially create alerts for in the future, so you're aware of the issue as soon as it starts taking place in the future, and kind of how to investigate that. And then there's also a financial component. In a lot of cases, you can directly tie uptime, availability, the duration of an outage to potential revenue lost. If you think about services like, if you take Starbucks for an example, a majority of the revenue comes through their mobile application when users are trying to purchase coffee in the morning. And if users can't buy their coffee, they might go to another shop, do those types of things, like Expedia, et cetera. If people can't book their hotels and their flights and different things like that, they'll go somewhere else. So every minute, every second of an outage is extremely crucial, and alerting allows us to reduce that numbers as much as possible and reduce those costs. So some of the fundamentals in regards to alerting, we'll kind of use some of these terminologies. Basically, the page is the actual event of somebody receiving a notification. It could be a legitimate event on a pager, it could be a Slack notification, an email, a text. And then you have the rule, which is basically the condition that needs to be met for an alert to fire. So that's going to be something like, if our millisecond response time for our checkout process is sustained above 1,000 milliseconds for 10 minutes, then we want to trigger an alert. Or if, different things like that, basically the criteria for actually triggering something. And then the alert itself is basically the manifestation of the rule and that condition being met, leading to a page, and somebody, hopping on it and taking ownership there. So this last kind of 5 bulleted items here, those are probably some good takeaways of kind of the whole presentation. But basically, alerts should always be urgent. If you're potentially waking somebody up in the middle of the night, or you're telling them to drop whatever they're doing to go investigate something, you should have created a rule for the alert in such a way that it is very probable that whatever is creating this notification is legitimate, that there's definitely an issue taking place, and there should be some urgency around addressing it as fast as possible. They should always be actionable. So, somebody receives a notification, there should be some next steps. Do you run queries? Is there an investigation dashboard you should look into? If it's actions that you're repeating the same thing over and over time, when an alert fires, hey, this alert, all I have to do is go reboot that machine and it's taken care of, then that should be automated when possible. They should be contextual. So whoever receives the notification should have the information they need to kind of begin investigation. And then, kind of tying back to Dylan's presentation earlier, best case tied to SLOs, SLAs, user experience, because at the end of the day, the main reason we're doing this is to keep our customers happy, keep our systems up and running, and then they should require human intervention and not be able to just be automated when possible. So some things to consider in the world of alerting. Creating meaningful alerts is not really a trivial task. It requires a deep understanding of the systems, the applications, the infrastructure, their behavior, their seasonality, their trends, growth rates. All these things are going to be factors in creating an alert that's hits that criteria we defined before. So it requires iteration over time, reviewing the existing alerts and procedures, following up with on-call rotations, documenting when certain things fire, having a record of all this, and it's kind of a long-term process. But they're crucial. They're necessary for achieving SLA, SLO goals. Just like in the last presentation, every second of air budget counts. We shouldn't be waiting for customers to file tickets, or people posting on Twitter that our app's down, or somebody waiting to see a big red spike on a dashboard. Automate these things as most as possible and optimize them so they're as fast as possible as well. And kind of going back to the first piece, this should all be documented. There should be plans, procedures when an alert fires. What are the next set of tasks that we do? Who are the SMEs in this space? Do we have run books that we should do? Have we built dashboards that allow us to take the context from the alert, maybe plug in a couple fields, and that'll give us, very far along in the process so we can have everything speedy and as optimized there. And then one other comment is alerting systems tend to have inherent latencies associated with them. So even though we're trying to bring this time, make the kind of this duration of when an incident starts or an issue starts and us detecting it and being aware, for systems like, log management systems, metrics monitoring tools, transaction handling services, there's just inherent latencies. Data has to be centralized. There's buffering, there's indexing, there's querying to run those rules or conditions. Those are on schedules. And then if it triggers, you might have to alert and notify a pager duty or a Slack, send an email. That kind of end-to-end delta of what takes place in that window is typically 3 to 5+ minutes with traditional systems when everything's been optimized to make it as fast as possible. So just kind of something to be aware of there. So we kind of talked about this in the last presentation as well, but I'll kind of speed through this. But basically, there's kind of this philosophy of symptomatic versus cause-based alerting. The general trend is that symptomatic alerting is the kind of recommended approach. There are cases when cause-based alerting makes more sense, but in general, symptomatic alerting is basically what can we potentially monitor from a user standpoint, an end user standpoint, that is an indicator that something is potentially starting to break within our system. So that could be an increase in 400 and 500 response codes, database queries failing, sustained latencies, response time spikes, et cetera. And so the goal is, having this customer-centric viewpoint where an end user isn't really going to care if your MySQL server goes down, or if CPU is spiking on one node in your 1,000 node cluster, and it's just going to get auto scaled and dumped out of there and won't be a problem very soon. What they care about are queries not returning, features not working, things taking forever to load, not being able to hit the checkout button at the end of filling up your cart, all those types of things. And so symptomatic alerting typically leads to less alerting measures required to have kind of a comprehensive visibility into your systems, and can be typically generalized. Whereas cause-based alerting is more looking for very specific things. Is the database down? Did garbage collection fail? Is Kafka message bus queued? In certain cases, it's good to have visibility in those types of issues, but a lot of cases for the systems, especially complex systems, it's very hard upfront to try to identify potential causes for issues and build an alert to detect that cause. It can require a lot of rules, and in certain cases, those alerts might trip, but not be reflective of a customer experience. A server's down, but maybe it's just failing over, and the end users, their queries are running fine. So just something to kind of keep in mind there. So what should we alert on? There's kind of 4 basic domains for things to look out for. The first being basic availability and correctness. So when somebody's using your your product, your platform, et cetera, are the things that they should be seeing, is everything up on the screen? Are there 404s or pages rendering correctly? Is everything correct? That's kind of a basic one. And then latency, how long does it take for things to load? Even as things go from milliseconds to seconds, or seconds to minutes, that can have a massive impact on the customer experience. People, typically aren't used to waiting for things when using software at this point. So any delays there can have a serious impact. Completeness, freshness, durability. Basically, if you're using something, you expect the results to come back accurately and complete. If you run a query, so the results being returned appropriately. If you're, checking out some items from Amazon, but 4 of the 5 things don't get delivered. You know, 4 of the 5 things get delivered, 1 of them doesn't. That's still an indicator that, you know, that the service is broken there. And then specific features. You know, if you're using Instagram, for example, and you try to post a picture, but it doesn't post, or, you know, try to buy a cup of coffee, book a flight, etc. You know, whatever your app's designed to do should have some visibility into each of those specific things, and that they're working appropriately. So there's this concept kind of taken from the SRE handbook of basically like LETS monitoring, which is basically an acronym for latencies, errors, traffic, and saturation. So latencies, what are request times, transaction times, response times, all of the timing that goes into transactions and processes within a system. But it's recommended that you make distinctions between successful versus failed error requests in their latencies. So if successful, 99% of requests are successful and they all take 1 millisecond, but then the failed request takes 10 minutes, and because that was your timeout limit that you set, you don't want that skewing your overall latency values for your systems. So having that distinction can be helpful, especially when you're setting alerts on some of those values there. Errors is another big one, probably one of the most common, looking at things like log levels, the distribution of error log levels to infos and warns and debugs, the distribution of standard error versus standard out in a Dockerized environment, 400 and 500. So these are typically, distributions of errors versus successes, the rates, frequencies, and those types of things. With traffic, you're basically looking at, it can be a number of different things as well. How many requests per second are taking place, the volume of transactions in a given window, how many concurrent sessions or users are taking place within a given interval, network IO. And so in a lot of cases with traffic, and this applies to some of the other ones as well, but traffic's a big one. A lot of times you want to align this with historical seasonality. So something like, traffic at 9 a.m. on a Monday for a lot of services is going to look a lot different than, 10 p.m. on a Saturday night. And so keeping kind of awareness around how applications fluctuate and those types of things will help kind of build good alerts for those. And then the last is saturation. So basically things like memory, CPU, IO, bandwidth, load. And for saturation in kind of today's world, in a lot of cases, this requires some additional kind of testing to see like what is the potential maximum load our servers can handle. If a single node's at 99% CPU utilization, but the other 50 nodes are at 10%, then it's probably not a huge issue. But if the entire cluster is kind of maxed out, then is auto scaling doing its thing? And is it, growing, and how fast can our system scale to handle these things? So, there's some different pieces there as well. So I'll go through a quick example of kind of the iterative process of creating an alert rule, kind of that condition. And basically this example is we're tracking the error and exception rate for a given microservice in one of our deployments. So if we take this kind of graph here, this might be the first step of basically, hey, let's look at the last 60 minutes and track, how many errors and exceptions took place per minute. And we say, in the last 60 minutes, it looks like everything kind of fluctuates between 15 and maybe 30. But then we had this thing happen at 1 p.m. where it jumped up to 65. Maybe our threshold should be set to 65, but we should probably look at a bigger window to see what is appropriate. So now if we expand to the last 3 hours, we see, well, actually that rate of 15 to 30 is pretty negligible when we compare it to whatever happened around 11:15 where it spiked up almost to 800. So maybe that should be our threshold for this window, for this alert, but we should probably keep looking as well. Expand into the last 6 hours. Hey, that's definitely still kind of the most concerning spike. We should maybe investigate what happened at that time, what generated all those errors. Did it affect users or not? But then there's also this thing that kind of a sustained spike around, 8 a.m. that we might want to also understand what the behavior was for that. We keep kind of bumping it up here. Look at the last 24 hours. We now see, hey, that spike, still that big spike on the right there, but now there's kind of there's a couple of these sustained windows. So maybe there's some, automated process that happens at that time that, generates some concerning things, but maybe it's not a big deal. So now if we go from one day to the last 7 days, we see there's kind of this, consistent baseline of, now we're looking at 30-minute chunks of about 750 errors per 30-minute window. But then there's these consistent spikes that happen almost, almost the exact same amount of errors every time, kind of on a similar frequency. So this probably is something automated that happens each day around midnight. So, we might want to investigate what that's about, but maybe that's not the right threshold. Maybe when we set an alert, we should filter out whatever this automated process is from our results, and then use kind of this baseline here of about 750 to maybe 1,000 as a threshold for something like that. Then if we bump it up to the last 14 days, we're kind of seeing the same data set there. Not much has changed between the 7, other than it looks like maybe this cyclical process started on June 30th June 30th there. So, something changed in that window that we might want to drill into. So now if we kind of do one last check, let's say, hey, let's look at, we have 30 days worth of data. Let's look back all 30 days. And then on doing that, it looks like, hey, there was a massive spike that happened around June 20th that completely trumps all the other data that we had for the previous 14 days. What happened this day? And we should probably figure out, was that an outage that took place? And, is this potentially the threshold we should really care about? So it's kind of an iterative process, requires, investigating each of these different things to kind of create a baseline that makes sense for the alerts, potentially filtering things out, filtering out noise. But that's just kind of one example of kind of a flow there to kind of do a deep dive. So now, hey, let's say we had set our threshold to, if there's ever more than 150,000 events per hour, we want a notification. Then what do we actually include in the notification? So whoever's picking up that page has the context that they need. So I think we've kind of touched on this a little bit already, but basically, context is king in a lot of cases when it comes to trying to quickly investigate and understand what's happening within a system. So in an alert, you might want to include all the various metadata tags that will kind of help point the responder to what's taking place, the systems involved, the services, AWS regions, all those things are pretty important here. In this case, this alert was a backend service is spiking in its 500 status code counts, basically. So the next question, kind of this quote at the bottom is, if I were the person responding to this alert, what's the first thing I would do? What's the second thing? What's the third kind of question I would ask about what's happening? If it just says, hey, 500 rates spiking right now, I'd probably want to say, like, okay, well, what is the 500 rate right now? And what has it historically been in a lot of cases? Or, okay, now I kind of know what these rates are. What are the top URIs that are contributing to this spike and things like that. So think about what, if you were kind of investigating something, if this alert fired, what's the additional context you could bake into the actual notification so you have everything there. So in this case, we might provide, what's the current distribution? It's 21%. Is that high? Is that low? Well, historically, if we compare this to 7 days ago at the same window, it was at 2.5%. So it's almost gone up 10x, which seems pretty significant. Our current count in the last 5 minutes is 540,500, response codes. Historically, a week ago at the same window, it was 36,000. So it's definitely a massive spike taking place. And then we can get some visibility into the top URIs that are affected. And then we might want to say like, maybe this gives us enough information we need to kind of know what's happening. But then we might want to also like hop into a dashboard that gives us filtering mechanisms where we could say, okay, let's filter on our billing service or the billing handler deployment and look at more details about what's happening in there and what led into it. So that's just kind of some of the basics there. And then there's some kind of advanced alerting tools that you can use to kind of aid with this process. So that example that I originally walked through of sort of eyeballing the data and looking kind of at historical trends to see what seems like a good baseline, that's kind of what we would call like a static threshold, which is probably one of the more common mechanisms of defining a rule or a condition for an alert. But there's also, a lot of tools in this space provide kind of creative advanced alerting mechanisms to make these more meaningful. So there's things like, historical time comparison. So this goes back to that concept of seasonality. Within a system, seasonality could be the fluctuation over the course of a day. It could be something like if you're working in like a school-based environment or education, you might have seasonality over the course of the summer, usage drops down significantly, but during the school year, things pick up quite a bit. So there's tools that basically provide what are called like historical time comparisons, where you might say, I don't necessarily care about comparing my current 60-minute window of errors to the last 60 minutes. What I really care about is, for something that like week over week comparisons, like if it's, the most traffic in our system is between 6 and 7 a.m. when users are ordering coffee, I want to kind of compare our current rate to the same day last week at that window and see what the delta is between those two. Day over day comparisons also make a lot of sense in certain cases, but comparing traffic on, Monday to the same window on a Sunday the day before, probably going to have some big fluctuations there. So for, seasonality based use cases for alerting, these historical time comparison tools can be really helpful. And then there's this concept of dynamic baselining. So basically systems provide basically automated ways to kind of figure out what a baseline or threshold is that makes sense. So they might pull a historical window and from that historical window kind of determine what a baseline is that makes sense, and then compare your current state to this baseline that it's dynamically created and use that as a mechanism to say if your current state's anomalous or an outlier versus what you were seeing before. So this kind of alleviates the use of static thresholds in certain cases, which can require updating. They might have, different thresholds based on the seasonality and changes. Your throughput rate today might be 10,000 events per second, but for whatever reason, all of a sudden your application is exploding and everyone's using it. And now that rate is now 100,000 per second. You probably are going to go back and update your rule to account for that, where these dynamic baselining systems kind of take that into account and take some of that heavy lifting off your plate. There's also predictive detection tools. So basically using like linear or auto regression capabilities to kind of monitor the seasonality or the trend of whatever you're monitoring and say, based on the current trajectory we've seen for some historical window, we think with some statistical confidence that you will hit this threshold you've defined in X amount of time. Based on the last 12 hours worth of data, if you keep at this rate, within 30 minutes, you're going to be above 90% utilization or above whatever your system can hold. So now we're telling you 30 minutes before it's actually happening, so you can go investigate that. And that can be really helpful for systems that you need that extra leeway for. And then there's kind of this concept of raw log clustering and additional context. So basically, especially when you're working with log data as kind of a telemetry data type, if an alert fires, in a lot of cases, one of your next steps might be, log into your Splunk, your Sumo Logic, Elastic, and run some queries to figure out what's going on in that environment. What these clustering or pattern detection tools do is basically say, we'll summarize all of these raw logs, which have different formats and structures. And, a stack trace is going to look a lot different than a 200 success health check status code. So it basically figures out what the patterns are between all these different raw logs and creates what they call like clusters or signatures, so that you kind of get, like, the analogy I like to use is basically a table of contents of, here's 100,000 raw logs, but there's really only 10 signatures that are happening. There's this stack trace that happened 99,000 times. That's the majority, the bulk of your data. And then there's these other events that are pretty rare. So it makes it really easy to find these voluminous, noisy events that contributed to potentially triggering the alert, but also kind of bubble up these unique events that would be much more difficult to find when you have a stack of, thousands of events to sift through. And that's another thing you can kind of automate, apply that to your alert context so that when it triggers, you have, the data you need to kind of quickly adapt and adjust, and do some of that way. And at one point, kind of sort of related to this, but not really, but I meant to say it earlier, like a lot of times when you're responding to a page, you might not necessarily be on your computer. You might be on your phone, which might not give you access to, look at a dashboard or do different things. So kind of think about what is all the context I could provide and automate as much as possible. So even if I am on my phone, I might be able to kind of do a quasi investigation with the data I have, or at least ping someone and say, hey, here's what I think is going on. Can you double check that? And some of that. So yeah, just some acknowledgement. Basically, some of the concepts here are taken from Google, the SRE handbook. There's another document, kind of monitoring distributed systems, which talks about those 4 golden signals that we talked about, the LETS monitoring. There's a great document by Rob Wozchuk from Google that's kind of this philosophy on alerting, which covers a lot of these topics, and then some ebooks there as well. So those are kind of some of the main pieces I pulled these from as well. And then kind of meant to tell this part in my intro, but I forgot this as well. So I'm currently at a company called Edge Delta, the Seattle-based startup, but prior to that was at, if any of you are familiar with Sumo Logic, it's kind of a platform in this space as well. And through that experience, had the opportunity to work with hundreds of organizations in use cases, building alerts, dashboards, queries, all these different things, and actually worked with a lot of Seattle-based companies. So I saw some familiar faces on the guest list there. So that kind of experience is what I'm super passionate about this space. Yeah, and that's pretty much it.
Thank you, Zach. Round of applause. Yeah. Round of applause. Nice job. All right. So now we get to have the fun hiring manager game. And we actually had a couple people sign up. All right. So first up, Dan Wilson. So I'm going to set a clock for 30 seconds here. And hang on. I got to figure out how to use my stopwatch. You get 30 seconds. And look at this. Urza, you thought she was paying attention. Turns out she was creating a slide for you behind the scenes. So here we go. I got my clock going. Dan, you ready?
Sure.
Ready, set, go.
So Control Plane is building a world-class service, and we're a startup. We're funded. We have a very strong executive team that has done this before, with the exception of myself, and have been successful at startups. We're 100% remote. We've been remote since the end of October. So we were remote before we had to be remote, and we plan on staying that way. And we're going to need lots of SRE to build this service. So check us out.
All right. Thank you, Dan. Good job. You were right on time. And next up, it is, Kevin Schmidt. All right. I'm resetting the clock. Tell me when you're ready. We'll start talking. The timer will start. Here we go.
All right, sure. So I'm Kevin Schmidt. I'm from UiPath. We're a very large late stage startup that's doing building automation for a bunch of enterprises. So we do have a large SRE team, but actually I want to promote a cloud infrastructure dev role. We don't currently have any roles in SRE, but we originally an on-prem company. We're in the process of moving to the cloud and becoming cloud first. We've got a great team here in Bellevue, and yeah, reach out to me if you're interested. 30 seconds is not very much time.
I know, but you did perfect.
No, that's good. That's good.
Here we go. We're trying to be a little bit more organized with our meetup planning. And so we have already set the next one on the schedule for sunny relaxation enjoyment. Get it? Get it? Jolene, you get it? Okay. And we're still looking for speakers. And I want to ask anybody here who's interested to speak. Maybe you're not, you don't think of yourself as a speaker. Maybe, you know, you haven't spoken before. You think your topic isn't that exciting. We're looking for people who don't do this all the time. We're looking for more diverse opinions, people who are earlier in their career. And we can fit you in with a shorter talk or a different talk. You can talk about a bug you like. You can talk about whatever you want. And if you need help, I'm happy to take time. I'll jump on a call with you for half an hour and we'll work something out together and you can do an awesome talk. So mark your calendar. Please go RSVP to this. Ursula will send out the link. RSVP now and secure your spot and we'll see you there in August. Okay. Awesome. Thank you, everybody. The other thing is our 1-minute survey. I want to invite back Dylan and Zach. And if there's any questions that other people have, you know, feel free to jump in. Any questions anybody has? Any thoughts, comments before I start asking questions?
I just was wondering if Dylan could, if he has a little more time, if he'd be interested in sharing a little bit more about QPS and was it the Wilson whatever. I wrote it down really quick and found it on Wikipedia, but we're just starting. Okay. We've gotten a couple golden signals that we're already really good at, errors and latency, but we're just starting on this traffic side of things and even saturation. So just kind of curious if you could talk a little bit more about it.
Sure. I was going to say, I was going to go find the Wikipedia page just to put in as if anybody's kind of curious. Okay, there we go. So I guess for some detail on how we've implemented it, it's a little bit of Python script, you know, in a module in the monitoring system, and it's really just transforming, you know, those inputs. What's your error rate? You know, what's your request rate? Only instead of just doing a simple division of errors divided by total, you have a function, you know, that does that math for you and gives you back a number that again looks like that percentage. But because of that curve, the low end of the curve basically gets a much smaller value, so that instead of, you know, 10% error, it's 1%. And again, that's kind of what that picture I was trying to show without getting too far down into the math is you're trying to lessen the impact of the error rate at a low QPS. And specifically in that particular formula, that's one that we use that works pretty well. And the Wikipedia page has a bunch of math. There's essentially a couple of coefficients that you can tune as to where you want that bend in the curve to be. You know, do you want it to be at 10 QPS or 100 or 1,000? And so you can kind of adjust it and play with it that way a little bit. But we found it to be a good way to get rid of some of those false positives, because nobody wants to be, again, to talk about alerting and Zach's presentation, nobody wants the 3 a.m. you know, alert when you look at it and go, oh, nobody's using the system right now. One user has sent one request and it failed, and it's related to just there's not enough traffic.
Yeah, which is we're struggling with right now because we do have a service that certainly has lower traffic, right? Like search is going to be super high, and then, you know, but actual like conversion to purchase, that's a lot lower. And especially in the weekends for us, it's a pretty low time, you know, so we were seeing exactly what you're saying as some of those false positives.
Yeah. So that's the way we filter that out.
Okay.
I'll see if there's a way to follow up with that. I'm making a note because you're not the only one that's asked me that question. I'll see if I can find something and see if Kit and Erzen can get it passed around.
That'd be great.
So I kind of have a question for Zach. I think drilling in a little bit on the symptomatic versus cause-based alerting. And Dylan, I'd love to hear your take on this too. How realistic is it for an organization, especially maybe one that's starting out in this path and it's used to monitoring causes, to switch to symptoms? What are the kind of like easy getting started steps? I mean, you kind of talked about the philosophy and everything, but what do you guys think about that? And like when is it safe to turn off your cause-based alerting? I think is my real question.
Zach, you got...
Yeah, I can try to start, and then Dylan, if you want to follow up there. So
Sure.
I think a lot of times cause-based alerting is can be found from, you know, after something like some type of issue has potentially taken place. So, you know, some issue took place, and then after the fact you said, oh, here's kind of the indicator that we ended up using to say, like, moving forward, if this happens again, here's the specific cause of that issue, and now let's start monitoring those types of things. Whereas on the symptom side, they're typically more generic in terms of what you're monitoring, in terms of like those fundamental components, the latencies, errors, exceptions, kind of those basic pieces. And even though they're relatively generic in terms of what you're monitoring, they're usually very strong indicators that something potentially abnormal is happening within a system. But there's kind of the generic aspect, and then there's understanding the fundamental components of your system. And so kind of like where that transition between cause and more symptomatic based kind of alerting takes place. I think it's just more of like an exercise of sort of kind of deciding to go that direction of, hey, we need to start implementing some of these alerts. What are the things we're going to look for? What are the potential choke points in our systems? What can our systems handle from a load perspective? And then, you know, in certain cases, the cause-based alerts are still valid and still a good sign. But in certain cases, they, you know, once you have some of these symptom-based mechanisms in place, you might get like duplicate alerts. You know, hey, this thing's firing, like your error rate's spiking through the roof, and also your database is down, and so now you're getting paged about a bunch of different things. So if you have, you know, there's systems that basically kind of mash all these alerts into a single notification, so you can kind of like connect them all together. But I think it's an iterative process and requires, you know, tuning and changing these things over time, and basically having someone decide, you know, hey, we need to actually invest in doing this.
Yeah.
I just had a follow-up question on that. So I also face the same problem that, you know, when we are trying to put cause-related alarms, we'll have some duplicate alerts, because those will also probably will be caught by user-facing alerts. So how do you actually deal with those kind of problem? Because the kind of combinations possible there is really hard to grasp, and we don't want to be missing out on certain aspects of our internal systems, which probably would cause a latent effect into the user facing alerts. We really want to capture that, but we also don't want to have duplicate alarms.
Yeah. So it's definitely not an easy challenge to solve. In certain cases, you have all these alerts in place. Hopefully they're not firing frequently to a point where there's, like, you know, the concept of alert fatigue, where basically it's people just start ignoring them. You know, you don't take them seriously. You get thousands of Slack notifications. You know, you have channels that you build up, and you kind of just forget about these alerts. So the goal is to basically create them in such a way, or like prioritize what channel they go to. You know, there could be a channel that's basically, if there's ever a notification in this channel, it means something serious is happening, where the other channel is like, hey, people keep an eye on this. You know, and if something major is happening, there probably are going to be multiple alerts firing all at the same time as, you know, systems start to break. But I think you can get creative with you know, if you use a tool like a PagerDuty or an Ops Genie, or, you know, even in ServiceNow, there's kind of like correlation or sort of like a transaction ID component that you can sort of tie alerts back to each other and say, like, if any of this suite of alerts fires, they're all tied to, you know, as our like hypothesis is they're all probably tied to a similar problem. So let's group them together. Not necessarily always the case. But yeah, it's you know, certain tools make it easier, but certain cases just, you know, hey, let's just accept if things are starting to break, like we're going to get a flood of alerts.
To add a couple of thoughts and give half of an answer to Tim's question. Some of it is based on system complexity, and I think that's kind of what you're getting at. You know, if you have, you know, 2 or 3 components in your system, then cause-based alerting may be just fine. But if you have 100 components, suddenly now you have all these different alerts that you're having to be, you know, all those different things that you're monitoring, all the things that might alert. If something goes a little bit wrong, suddenly everything, you know, you get all these alerts. And so there's kind of a break point in there where doing symptom-based alerting starts to make a lot more sense because of the size and the complexity of your system and your architecture. And so, you know, again, to kind of give a half an answer to Tim's question about where do you put some of this, you know, some of my experience is you put the system-based alerting out on the very front, but you still have a little bit of cause-based alerting, you know, like, you know, is the thing alive? You might scatter that at every layer, you know, just to kind of give you that, you know, that ability to see, well, what's the, you know, what are all the pieces in the system? And, you know, if I put them up on a graph, you know, do I know which box is red? But you don't necessarily have to do all the latency and all the correctness and all of that down at that level. You just want to make sure it's alive, and you start to push more stuff out to the farthest layer to the front. So,
Okay, thank you.
if that helps. Because yeah, pager fatigue is a real kind of thing, you know, in that when someone's dealing with these things, you want them to have kind of a confidence and, you know, a focus, and, you know, getting 10, 20, 50 alerts all at once, and then trying to go, okay, how do you put that all contextually together, you know, makes it is hard for people. You know, it's much better to have a, you know, very single focused thing to be working on, and, you know, start with a known place and be able to have playbooks and all of that kind of stuff tied to it.
I want to read something from Twitter because I took a screenshot of the symptomatic versus cause-based alerting and tweeted it while we were talking. And somebody wrote in response to that, the way they bend together is when you get a symptomatic alert based on breaching SLO, of course, or high velocity towards it, and in that alert you get the cause-based info. And then that means you probably should have automated fixing it too.
Yeah.
Is automated resolution, is that feasible? How realistic is that? And if you have cause-based and symptomatic alerting, how does it affect your strategy for automated remediations and like global rollbacks and global data center drains, things like that?
Yeah, no, I will say that's not easy. I'll say that, at least, you know, to speak a tiny bit about what I work on, we do a little bit of that, but that's non-trivial to set that kind of infrastructure up. But it's important if you have something with a very, very, very low tolerance. You know, to go back to some of the numbers earlier, if you start talking about 3 and 4 nines, you know, especially 4 nines, then you start to reach a point where human reaction is not fast enough. You know, the tooling is not, you know, just having the monitoring system generate an alert and having to go out to your paging system and SMS, and, you know, suddenly you've lost 3 minutes just getting the page, and then it's going to take you 3 more minutes to like actually read it and get to a computer, and your SLO is gone. You're already negative, and you haven't even tried to mitigate it yet. So yeah, it's definitely a thing if you're going to be at that tight of a tolerance.
One more question I had, if I can ask one quick question.
Yeah.
So how do you suggest actually setting thresholds? Like we were talking of anomaly detection for traffic graphs. But even for regular graphs, do you actually look at historical data and that's how you set? I think Zach also like showed bunch of graphs where, there was something based on 7 days old, 30 days old, and so forth. And that kind of makes a very tough decision on what threshold should be put on those metrics. So is there any suggestion on how that problem should be approached?
Yeah, I think that's a good question. That's probably one of the most complicated pieces about creating useful alerts is basically taking the time to do the analysis with the data you have to basically decide, if we're going to use a static threshold, what threshold makes sense. And if we're picking some baseline, what can we potentially filter out that will kind of make that baseline like an accurate representation of normal state versus a potential fluctuation that is meaningful. But then there's a lot of times like the most realistic and like definitive alerts that I've seen in environments are typically like they'll use some of those more advanced functionalities, like comparing the current window to another window at another time and seeing if those have significant deviations from each other, things like that. So it's never really an easy problem to solve. I think every alert basically requires some analysis, investigation, testing things out, and you might not get it right the first time, which is fine and kind of expected. But maybe let it run for a few days and see how it responds before it's actually paging someone. Like keep an eye on the results. But then you say, okay, this is ran, like it actually did detect the thing we wanted it to detect, so this is probably fine. Or hey, it's paged us 50 times in the last hour. We probably need to go, change one of the settings there. Yeah.
Are you actually going backwards from SLO to setting your thresholds, or you're basically looking at historical data and say, oh, this is going to be our SLO?
Probably a little bit of both. I mean, I think in defining those numbers, you'll definitely look at your historical value and basically say, like, what can we agree to setting as this number that we're going to make, public facing and provide to our customers. But I don't know, Dylan, you might have a better answer for that.
Yeah, I would. Again, I kind of think I said that in my presentation, but yeah, you really, if you can, there's always circumstances, but you try to start with your historical data and say, okay, what's my availability been for the last 30 days? Okay, that's where I'll start to build an SLO from, because if you try to make your SLO, pick an SLO and then work backwards, one, it could be very aspirational, and suddenly, okay, you went 3 nines, but your services were only doing 2 nines. You're going to get alerts all over the place, and that's not a healthy state to be in. So, I would definitely suggest try to understand your system really well to begin with. And you might also find in there, again, going to customers, users, what's their expectation? It's very possible that, if you want to set your SLO 1 9 bigger than what the customer expects, then that's a lot of work and a lot of expense that's not going to get you, any more positive sentiment or any more positive result from the user, because they're already happy with the system.
There's an implication here, I think, for the relationship between development teams and SRE teams as well, and maybe that's something to think about, which is if you're signing up to carry the pager on behalf of your dev team, there's probably some sort of proof that you want that's not gonna, you're not gonna be completely bearing the brunt of the pager going off. How do you think about that? I know there's a very specific process for that at Google.
Yeah, I was gonna say the Google answer probably isn't as applicable to everybody else, but for us, we require the dev teams to carry the pager to begin with, and only when it's in SLO do we take over and then begin doing the production side of it. And that mileage varies a little bit team by team, but that does tend to kind of get things level set pretty well at the beginning. Devs don't like to be paged any more than SREs.
That philosophy works extremely well at an 11-person startup. I can say that as well.
Yeah.
I would definitely say at Getty, we don't have an SRE team or SREs, so it is our devs who get paged for SLO misses.
Yeah.
And
So
we
Jolene,
use, yeah, go ahead.
Oh, I was just going to say, so I think I cut you off. I apologize, but I was going to ask, like, so what are the consequences then in that situation? It literally just comes down to my own work-life balance is affected, or what? How does that affect the culture, I guess, around reliability for the development team?
Yeah, and so, again, we're still in the process of changing mindset, trying to get people to think where we used to think about things being hard down to now things just being degraded service, latency is bad, so we're trying to catch people kind of up with customer expectations in that sense. And when we migrated to the cloud, of course, that kind of the wall that used to be like, well, that's ops, and ops takes care of all that stuff. And, so I think we kind of have a lot of things moving at once. So we are revisiting kind of these ideas about how to, it was said in the presentations, how do these SLOs equal customer satisfaction or dissatisfaction? And we need to, once we're not meeting those objectives, and that is a hard place to get to know whether your SLO equals that customer satisfaction or dissatisfaction. Like, where's that bar? Where do we set that? Is that 99.9% at, 100 milliseconds for something? You know what I mean? Like, that's a hard number to actually get to say we think once we're reaching this that we are creating dissatisfaction. But ultimately, once we've kind of, said, hey, this is where we're going to start, and maybe it's not right. So Zach, what you were saying, like, this is a process of iteration. But once we kind of like start watching that, but like, so here's a real world example on one of our services, we had a degradation of 10x in terms of latency. So it was a 10x latency, and I would say it was a pretty relaxed threshold to begin with, right? It wasn't something super tight. We're talking something in the multiple seconds in terms of latency on this service already. And so being able to have that conversation and just say like, well, let's really think through what that means to have a 10-fold increase in our latency. We've gone from almost to a minute at this point. So think through this process as a customer. What are you doing? You're probably spamming the button right now, or whatever. Or you're like, this is the third time this has happened to me this week, or whatever, right? And so trying to map that back a little bit better so that devs kind of understand a little bit better of like, this is what our customer experiencing, and this puts us vulnerable. This makes us vulnerable to them, to a new customer bouncing, or a current customer getting frustrated and saying, I'm not going to shop there anymore, right?
Important consequences these days. Unreliability is expensive, especially as everybody's online now.
Yeah. I guess as a follow-up comment that some of the critical user journey stuff that I was talking about, one way to start that is to look at if you've got customer feedback or customer support tickets or angry emails, or however that works for your individual situation. That's sometimes a good way to find some starting information, like what is it they complain, what's the complaint, is it a failure rate or a latency or some weird error or correctness, that is a way to kind of find some of that starting information.
Do you actually go around, or do you have any process to test your alarms themselves? Like, just go through all the alarms and make sure that they are working right, they have the right thresholds, they're not disabled, things like that? I think either one of you can answer. Yeah.
I think that's a common use case for like chaos engineering. Essentially, is basically hey, we have all these pieces in place. Let's run some massive load tests, or basically spawn something that's going to create significant impact on our services. And even leading up to that, you might make some predictions like we expect these specific alerts to fire. That's what they're designed to detect. But yeah, that's a good question. There's some tools that can kind of help with that piece, but there should definitely be some kind of diligence around making sure that everything's up. These alerts are running, because there are settings and configurations that can change that could disable them, or the Like if you're looking at log data, the metadata tags could change, or with metrics, same thing, the metadata tags could change and all of a sudden they're no longer, generic enough to work. Yeah, so it's, it's definitely something that you should kind of keep track of. A lot of times we'll see people who basically like record every time an alert fires and what led up to that, and basically have this kind of monitoring on the alerts themselves. When's the last time they fired? Are there alerts that seem to be continuously going off all the time? Okay, let's go back and let's change those and tweak them. Is there alert that we haven't seen for a very long time? Certain alerts, it might be basically a fallback to where like we never expect this to happen. And if it does, it's definitely a signal that something's happening. But like, yeah, there's things you can do to kind of test them ad hoc a little bit. But yeah, I think that's a really good point, making sure that, because they are so fragile in a lot of cases, that you should have some process around making sure they're always up to date.
And I think also, just to jump in here, that's also a really good use case for making sure that you're backing up the logic in your alerts with visual representations. So if you can eyeball a dashboard and you can say, okay, that's really weird that we didn't get an alert, but our dashboard is showing 10x or 100x spike in some specific metric or any type of feature, then I think that's really great to be able to back up the logic that you think should be firing off or should not be firing off with a visual or a graphical representation.
Good point.
I wanted to, if you'll indulge me for 1 second, I wanted to go back to something Tim said, kind of in jest, Tim Johns. I'm going to put you on the spot for a second, because having been a startup guy and a big company guy, and I think some people are somewhere in the middle most of the time. On the one hand, big orgs do have those boundaries where you do have to kind of set these consequences and consult across groups. But you're right, in a startup environment of 11 people, you can't really, just say, well, I'm not going to do whatever. And, it's a very good point. And so wearing more hats, and to Jolene's point, right, they're not dedicated SREs. But Tim, what has been your experience with trying to drive reliability, especially in the face of, constant pressure for features, small teams, limited resources, limited roadmap? How do you handle that? I'd love to hear your thoughts.
Yeah, thanks for asking. First of all, I wasn't kidding. I actually think when you're at a tiny growing company, setting the culture up with the philosophy that the devs carry the pager until it's been more further operationalized is actually an awesome way to start. A 3-person startup, you're the person on both the ops and the dev team, so it doesn't work as well. But 11 people, you start to see a little bit of differentiation there. And so I wasn't really joking so much about that. And then to answer your question more about the what do we do there? That is a good question. Different people have different philosophies there. If you have a dev who is absolutely 100% not interested in ever waking up ever and didn't sign up for carrying a page or whatever, there's some real danger that what you might be doing by asking them to do so is encouraging them to sort of overbuild everything. And then that pressure you mentioned right there becomes critically important, because you don't want to spend a lot of time overbuilding your infrastructure for reliability and scalability when you haven't had a customer, for example. Getting the customer to actually use it is a great way to see some of these things operationalized in production too, and then you don't have to fake it. And then later on down the road, it can work against you the other way too, meaning once you've had no outages for a long time or whatever, it's very easy for the product team to come along and go, are you all over investing in reliability? When you're like, no, this feels really good right now. Let's not mess with it. And, I've been through both, quite frankly, at a tiny growing startup. I've seen both the reaction to the concern about getting woken up cause some sort of massive over engineering. And then I've also seen, product folks very upset at the quote unquote sandbagging that's going on there. So you just have to be open and transparent and try to get everybody on the same sheet of music. And I think that probably scales across the tiniest organizations to the largest organizations, just harder at the larger organizations.
Thank you, Tim. Thank you for sharing that. I appreciate it a lot. We had one more question here, JT, on the chat about sample dashboards for monitoring a J2EE application. Okay, you have to leave. Sorry. What are you talking about? J2EE in here. I'm kidding. I'm kidding. That serves a single pane of glass for his entire application. We still have some in APM, some in Splunk, etc. Does anybody have any thoughts on that? Anybody want to venture into the world of J2EE?
I'm afraid I don't know anything off the top of my head. My prior experience with that sort of technology, we built all of our own. And what I use in Google is internal, so that doesn't help either.
Yeah, this is Zach. I don't have any specific examples here to share as well, but I think, going to your comment of, do we still have some in APM, some in Splunk, et cetera, or a microservices app? It really depends on the tooling that you're using. Certain tools today support, basically the primary telemetry data is you're going to have your log data, your time series metric, and, potentially distributed tracing. Certain platforms, you can throw it all into one system and kind of, build a dashboard that shows all three. Others, certain tools were purpose-built for logs and another was purpose-built for metrics. And if you want the best of the best, as of today, you might be using different tools for those different things. But there are ways to, if you really want that end-to-end picture and kind of a single dashboard, there are ways to extract the data from those tools and kind of build your own tooling that uses those APIs or uses iframes to pull, widgets from certain tools, things like that. If that helps, but yeah.
Yeah. The one pane of glass is usually there's lots of one panes of glass, it turns out. But... All right. Oh, go ahead. Yeah.
I'll give you a 2-second thought on something there. One of the things that we do, and this could be a whole nother talk, we build a playbook for every one of the alerts, and we just put all the links for stuff like that in there. So it may not be one pane of glass, but it's all connected to the alert. So you can have a link to where the logs would be, and where the monitoring and different things like that are, and then you just kind of build it for every alert and every scenario, and you're not trying to maintain this complex UI. So anyway,
yeah, it's good.
I think we're about out of time.
Yeah, we ran a little over, but that's okay. We kind of always do, and it's always a lot of fun. I really want to thank, again, our speakers, Dylan, Zach. Thank you, Angela, for coming and sharing your data. And thanks to everybody else who jumped in with questions, stuff like that. We really appreciate all the loyal folks. We're signing off now, and we'll see you next time. And please, if you're interested to speak or do anything else to help out, hit me up. Thanks, everybody.
Thanks, everyone. Bye.
Bye.